First, I think it is very important that we understand what a citation and a reference are. Sometimes we use the two words meaning the same thing, which is fine, but there is a little bit of a distinction. A citation is when we cite our own work or other people's work. And here, according to Cornell University, a citation occurs when you use a specific source in your work and then follow up with the proper bibliographic information. The proper bibliographic information is the reference. And the reference goes, if you're following APA style, it goes at the end of the paper you're writing. Of course, it will depend on the style. But in the case of my class and in the case of the style that I'm requiring, normally in the program, it's APA. Other professors have other preferences. But in APA, you cite in text and then you reference at the end of the work. And the reference is the bibliographic information that guides readers to your source. So when you're writing a paper and you cite somebody else's work, you would put the last name and the year. That's the citation. And then you have to reference that citation in the reference page. Why? Because you want your reader to be able to follow your citation. And citations or references, in this case references, is what we use for citation analysis and bibliometrics. Okay, here we have an example of a reference in APA style. In this case, it says Tenopir C. Valentine R. King DW 2012, and then the name of the article and book reading patterns of scholars, finding for publishers, then the name of the source, Learned Publishing, and then the volume, issue, and pages. So with this information, what we do is we apply bibliometrics and citation analysis. We have another example too of a reference, not anymore in APA style, but as an output from a database. In this case, the article comes, the source meaning the journal name is Library and Information Science Research, and then we have the volume 31, issue 3, September 2009, and pages 135 to 148. Then we have the title of the work, variations in article seeking and reading patterns for academic, what makes a difference. Then we have the author's name, Tenopir, King, Spencer, and Wu. We have then affiliation, and it's right here, it's kind of small, but you can see it here, and that means institutional affiliation. Then we have an abstract. Then we have other things like ESSN, and we have original language, document type, etc. All of this information is very important for doing citation analysis and bibliometrics, because we don't only use the reference here in APA style. We may use affiliation because we are interested in measuring input and impact of universities, labs, and other institutions. So having the institutional affiliations such as the University of North Carolina and the University of Tennessee in the record, it's important for bibliometricians and citation analysis research. It is not important when you are writing a paper and you are citing at work, and then you when you do your reference appears in the reference. You don't put the institutional affiliation information because it's not important. But for bibliometrics and science citation research, it is very important to have the affiliation, and I will show you why in some examples. It is also important to have the abstract and the keywords too. Abstract is important because we can mine what it is in the abstract, and we can make knowledge maps. And the keywords too, because we can identify what the main keywords are, and we can relate keywords one with another. Another very important piece of data is source type, because in bibliometrics sometimes we want to do bibliometrics on journal articles or letters to the editor, etc., etc. This is what we call typology, document typology. So that's another indicator that sometimes in bibliometric research becomes very important. Okay, so I just wanted to show you an APA reference and another bibliographic information. In this case is not in any particular style, but with more information if you want to do bibliometric or citation analysis research. Then what you use, you would extract the information from the bibliographic record and build up your own database in order to apply statistical measurements. And what are some of the units of analysis that we're going to use when we apply numbers and statistics? Well, and I think I've mentioned in the prior lecture, we do that with journals or source. We do it with individual scientists or academics, with groups such as department, college, university. Even geographic areas are important for bibliometric and citation analysis research. For example, we would like to know what the scientific production of Pennsylvania is. We have many universities in the state of Pennsylvania, so we want to measure what is the productivity in terms of scientific papers of Pennsylvania. That would be an example of a geographic area bibliometric research or citation analysis. There is another concept which is very important, and it is related with what we call the research front or the invisible college. And the invisible college is a concept of scientists working together who are not in the same organization, meaning that and this is true about science, and it's now even it's happening more and more because we have the internet, we have of course we have telephones, we have other means of communication, but especially with email, collaborated work, Google Docs, etc. So now scientists from all over the world collaborate, and they become an invisible college. Why is called an invisible college? Because even though they collaborate in doing some research, they don't belong to the same college or university. So one scientist may be here in Pennsylvania at Penn State, the other may be in South America, in Brazil, and the other researcher may be in Japan. Well, they become an invisible college. Okay, and this idea came from Price. I think we read an article by Price in the first week of the semester, and he talks about invisible college. Even though he wrote that piece in the 1960s, he realized that scientific collaboration means scientists from different organizations collaborating with each other. Now, of course, this is even more relevant because we have the information technologies. Okay? So that's the idea of the invisible college. Then we have another unit of analysis, maybe disciplines, and as I mentioned before, also document type or typology. Okay, these and there may be others too, but in my opinion, these are the main units of analysis that we use when we do bibliometric and citation analysis research. Let's see now some examples. For example, when we want to measure scientific output and productivity, and the idea here is to measure papers published. Okay, and paper published, we can make up indicators when we have another variable. For example, paper published per year, paper published per department, paper published per discipline. By the way, all the graph and tables that I'm presenting today, some are in Spanish, some are in English. They come from research that I've done in the past. So I don't have the citations there, but it's my own research anyway. In the first one here in this table, what we have here is paper published by the Natural Science College at the University of Puerto Rico, and we can see the publications by year and by the department. So, for example, biology is the first one, had 50 papers published in 2000, 55 in 2001, 43 in 2002, 39 in 2003, and so on. Then we have chemistry, physics, and math. And the total production, or the total papers published from 2000 to 2003 is here. 839 papers were published by the Natural Science College from the University of Puerto Rico. The same thing here. And let me put it bigger so you can see it better here. It's a percentage of contribution by department from the Natural Science College from 2002 to 2003. Of course, the information comes from the Science Citation Index 2004. That's when I did that research. And here what we are seeing in this pie chart is that chemistry had 46.36% of all the contributions in the Natural Science College, followed by physics, then by biology, and finally by math and computer science. So this is one of the things that we can get when we analyze scientific output. In this case, for example, we have scientific output by department. So the unit of analysis is not the individual scientist, but it's a college within a university. In this case, the Natural Science College, and within the college, every department: math and computer science, biology, chemistry, and physics. Okay, so this is one example of scientific output and productivity. Let me go to the next slide here. Here we have a measurement of scientific output and productivity on disciplines. For example, this comes from a research that I did many years ago on Venezuelan scientific output, and what I discovered doing citation analysis and bibliometrics for the country of Venezuela is what we have here. And this is for disciplines. Okay, so we have and we have a percentage of the whole scientific production that was indexed in the Science Citation Index for 10 years. I think it was the research. So here we have, for example, physics and astronomy 13%, clinical medicine 13%. So as you can see, it's very evenly distributed here. Okay, and we have a detail here of this. We have math 4.89%, earth environmental science 4.41%, multidisciplinary science 3.11%, and computer science 1.49%. So these are examples of things that you can do when you do citation analysis and bibliometrics. Let me see here. We have another paper here. Let me move this a little bit here so we can see this one easier. Put this one smaller. Okay, and here we have this came from the same work that I did at the University of Puerto Rico for the Natural Science College from 2000 to 2003, and we have a distribution of publications by subject. So as you can see, and that's what we saw before, is most of the publications, 128, were published in chemistry and multidisciplinary science. Then physics applied, physics condensed matter, physics atomic and molecular and chemical, and so on. Here we have zoology and with 11 contributions and a percentage of 1.5. Of course, there may be others that had less contributions, but I did this graphic on this threshold. So this is another indicators on disciplines and areas of knowledge that we can mine that information when we study citations. Let me see the next one, what we have here. This is very interesting too, and this is also comes from the same study in 2004, and we have what I call productivity per capita. So the indicator was produced by dividing publications divided by number of professors. And what we have here is that we have an average here of one publication in 2000 by biology. It increased a little bit in 2001, but then it decreases again in 2002 and stays more or less the same. Physics, for example, here we have it's the highest productivity per capita, even though, and we can compare, before we said that chemistry was the department with more output. Well, in terms of productivity, physics score higher because they had less professors. So sometimes one indicator, one thing is output, and the other indicator may be productivity. So in this case, physics was more productive than chemistry, even though there were more scientific production, or more. When I talk about scientific production, I'm talking about paper published index in the Science Citation Index. So there were more papers indexed by chemistry, but physics was more productive. Okay. So this is another type of indicator that you can construct. And so what indicators you construct, it will depend on what you want to show. Okay. So in this case, I was doing a report for the chancellor of the university, and he wanted to see how the money was being allocated in the natural science department, and he wanted to see what were the most productive departments, the most department with more production, and who were, I don't have them here, but who were the most productive faculty. Okay, so depending on what you want to show in your research, you can go by output or you can go by productivity, and you can construct your own indicators. And this is very important too when you're analyzing funding. And I think for next week I have another report that I did for Cresca Tech, which is a lab on scientific production and productivity, and I have a little bit more complex indicators that we're going to see next week in the next lecture. Okay, here. And this is, remember when I was beginning this presentation, I was talking about typology, document typology, and it is very important, of course, because you want to show that what is being published is research. That doesn't mean, of course, that other types of publications are not important. But again, it depends what you want to show in your research. Here, what I am showing here is that most of the publication for the 4 departments were concentrated in articles, research articles. But this is very interesting to see too. For biology and for chemistry, there were also a good number of publications in meeting abstracts. That means conference, which is also a very important type of document. Okay, there were, of course, book reviews, corrections, editorial materials, letters, and reviews. But in general, for scientific production, what we're talking about is research articles. So that was very important also for in this case, for the chancellor to see how time and how how time was being spent by the faculty and what type of documents they were publishing. So document typology is also a very important indicator. This is a very interesting graph here. The idea here, and there's one law in bibliometrics called the Bradford law, and the idea is that scientific production is concentrated in a small number of journals. Okay, and that has to do also with citations too. And that's what, for example, when I was talking about the Science Citation Index and the in general of Web of Knowledge, even though they index only about 8,000 journals, most of the citations that are most of the work cited every year come from those 7 to 8,000 journals cited index in the Web of Knowledge. So there is a concentration, and we call it journal production concentration. For this research that I was doing, and let me show you here, we have group 1. In group 1, there were 21 journals, and that accounted for 1% of all the journals that I researched. This research was when I was doing the citation analysis for Venezuelan scientific production. So 1% of all journals meant, and this is this color right here in the middle, even though only 1% of all the journals contributed account for, I'm sorry, the word is account for 20% of all paper published. So group 1 here and group 1 here. So you see this small group here only accounted for 20% of all papers published. Why? Because there is a concentration in terms of publications and in terms of citation. This is what we call the core collection. So the core collection was only 1% of all the journals that were 21 journals, and 21 journals accounted for 20% of all the publications for that period of time. That's my core collection right there. Then we have group 2, and in group 2 we only have 8% of all journals, but 8% of all journals accounted for 30% of all papers published. So if we add group 1 and group 2, we would have 9% of all journals, or 9% of all journals, and we will account for 50% of all the publications. That's the core of our publication. That's the core collection. Okay? If we see group 3, in group 3 we had 91% of all the journals, or 1982 journals, and 91% of all the journals, group 3, accounted for 50% of all the publications. So you can see how the concentration was in group 1 and group 2. 9% account for 50%, and the other 91% accounted for the other 50%. So in terms of collection management or collection development, if you have to make a decision into which journals you're going to get because you have lack of funding, what you have to do is you better go for group 1 or group 2. The ideal, of course, is to get group 1, group 2, and group 3. But if you can, get first group 1 and then group 2, because this is only not for production or scientific output. It also counts. It also works in terms of citation. In other words, there is a concentration of production, scientific output, and a concentration of citations. So if I didn't measure it in this case, but if I would have measured it, I would have found that probably 10% of all journals accounted for even 60, between 40 and 60% of all citations. In this case, the graph is about production. But if you go and analyze citations, you will find the same thing too, meaning that your the scientists that work in your institution will use a small number of publications. And that small number of publications, of course, are the publications that have more impact. Okay? And that accounts for a large number of citations. So this is what I found. And this is very important for us librarians, especially in our environment when we have limited funding. Okay? So this is a very important indicator that we librarians can use for collection management. Of course, and this is something that we have talked about too in the previous lecture and you have read about, is the famous impact factor. And I got this from a database. They like to publish their impact factor. So in this case, this is an example. It's called Academic Pediatrics. It's the official journal of the Academic Pediatric Association, and you can see here they have the impact factor 2.398, and they also have the 5-year impact factors. Now they have two measurements: the 2-year one and the 5-year one. Okay, and of course, impact factor is it's an indicator of visibility. It means how visible the journal is. And they have that information there because they know that scientists, for example, one scientist that works in pediatric research, he will publish in journals with high impact factor. Why? Because he's looking for more visibility. He's looking to be cited. Therefore, he won't be publishing in journals that don't have impact factor. Why? Because nobody will read those journals. That doesn't mean that his research or her research is a bad one. It means it doesn't have the same visibility. And this is why citations and scientific production gets concentrated in less and less journals. Okay? This is one of the reasons why. They also have, and this is very interesting here, they have most cited articles. And you can read what are the most cited articles. That's another indicator of impact and visibility. Again, impact and visibility does not mean that that they have their research is better or worse. It means that it has more impact and more visibility within the scientific community. Let's see this. Okay, this is a very important indicator. It's called collaboration. And collaboration means how many co-authors do you have in scientific production. And here we have one study that I did also many years ago, from 1994 to 2003, to see what were the average of co-authorship per paper. And we see that in 1994 was almost 2 people, between 2 and 3 people. By 2001 we have almost 3 to 4 people. And this is very important too, because a measure of impact and visibility has to do with collaboration too, especially in terms when your unit of analysis it's a country. You want your country, especially if it's a country from the developing world, to have a larger number of co-authorship. Especially you want your scientists to collaborate with scientists from the core countries, to collaborate with scientists of the most advanced nations. Why? Because you want to have visibility and you want to have impact too. And because that means more funding. Okay? So everything has a reason here. So then we see after 2001, collaboration average starts decreasing. I didn't follow up the study. I would like to see what happened from 2003 to 2012. But this is a very important indicator too. And of course you can, and I will show that later, with institutional affiliation, you also want to correlate co-authorship, average of co-authorship with institutions, because you want to see your production, or you want to see your scientists collaborating with scientists from main research centers, from core research centers, and you can measure that too, and I will show that too in a later lecture. Then we have indicators of visibility and impact. Of course, we already talk about the impact factor. Well, we have other indicators that we can construct. We can have cited articles. We can have cited articles per year. Or we can have cited authors. If you are a researcher, you want to see how many cites do you have. Citations per year, that's another indicator. Citations per article, and we have one too that I'm going to talk later, not in this lecture but later. One is the H index that it has become very popular, and that's to and what you do there is you get a number that compares papers published and citations, and or times cited, paper published and time cited, and you as a scientist get a number, and of course the higher the number, the more efficient or the more productive you are. And then we have also a more complex indicators that we use, correlations. We use other types of statistical analysis that I'm going to show you next in the next lecture. Only one example I have here, and this is what I did too, and I'm going to show you this because it's very interesting. This is how every institution, what is the distance between the institutions and the knowledge areas, and the knowledge areas according to the production. For example, we have this institution called Intevep right here at the top. Well, they are producing mostly in engineering science, and they do also some scientific research on earth and environmental science. However, UDO, which is another university, they also do a lot of biological science and do some earth and environmental science. USB, which is another university, here they do mostly chemistry, some computer science, and some math and statistics. CIDA here, CIDA, another institution, is mostly doing research on physics and astronomy. By the way, the more you are closer to the center, it means that you do a little bit of everything. However, when you're in the periphery, like this one, INIA here, INIA, they do mostly agriculture and food science. So with this graph of proximity, it's called institutional proximity and knowledge areas, you can see where each institution is publishing more research, and that's why it is very important to have in your bibliometric or citation analysis research to have institutional affiliation. For other indicators too, as I said, you want to see who you are collaborating with in terms of co-authorship, but in terms of also matching or correlating the institution with a knowledge area, it is also very important that we have institutional affiliation, because what we can see here is that, for example, EVIC here, which is at the center of this graph, well, it means that they are doing research on these knowledge areas: chemistry, physics, biomedical science, and basic life science. But the other are very specialized. Okay, INTEVET does engineering science, and INEA and UNESR, they do agricultural and food science. And why is this important? Because with this you know what these institutes and universities are producing in terms of new knowledge, and you can allocate funding. The unit of analysis here, of course, were universities, but you can use the same technique to identify areas of knowledge for smaller units of analysis. For example, for departments, as we saw before. This is another way to present the same information, because you want to know where are your scholars, what your scholars are researching on. So these are some of the indicators that complement the readings that you have done this week and last week: Okubo, Glanson, Winkler, and Winkler.